awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula.
Alright, so for this video, this is the last video for chapter 6. So we're going to discuss example number 9 and number 10. Okay, so let's read the question first. So here we have a woman rides a Ferris wheel at radius 15 meter, completing 5 turns in every minute. Wah, laju ni. So daripada maklumat ini kita boleh tahu kelajuan betapa lajunya Ferris wheel ini bergerak. Okay, so actually we can find omega. So question give us that 5 turns, which is 5 revolutions, turns ataupun rotations in every minute. That's mean per minute, in 1 minute. Okay, so this is actually the information about omega, angular velocity ataupun kelajuan, berapa kali dia boleh complete pusingan lengkap. Okay, so before we proceed our calculation, so make sure we change 5 turns per minute into radian per second. Okay, so this one should be turns. So 1 turn, 1 complete circle equal to 2 pi radian. So we can cancel. And then minute kita tukar kepada second. So 1 minute is equal to 60 seconds. Okay, so omega you kira you akan dapat 0.524 radian per second. Boleh. Okay, so A, the period of the motion. So the period of the motion referring to the time taken to complete 1 circle, 1 revolution. Untuk lengkapkan satu pusingan lengkap, berapa masa yang diambil. Itulah maksud dia, the period. Okay, so A, so we want to find capital T. So since we have value of omega, cuba ingat balik formula yang relatekan omega dengan time. Kan kita tahu omega is equal to 2 pi f. Another one is omega is equal to 2 pi over t. Remember? So from this equation, I will find t is equal to 2 pi over omega. So we can substitute 2 pi over 0.524. Therefore, t to complete 1 revolution, untuk lengkapkan satu putaran, Ferris wheel ini mengambil masa 12 seconds. Laju ni. Kan? Terlalu laju pula saya rasa. Okay. Alright, B. Calculate the magnitude and direction of her centripetal acceleration at the highest point. Okay. So now look at here. This is the highest point. Okay. So the direction should be downward. The direction of the centripetal acceleration should be downward. Okay, so direction dah ada. So now we want to calculate the magnitude. So magnitude, so AC is equal to V squared over R. And remember, V is equal to R omega. So AC juga kita boleh tulis sebagai apa? R squared omega squared over R. So AC kita boleh tulis sebagai R omega squared. Boleh Okay, so let's substitute R. So R is equal to berapa tu? 15 meter. And omega is equal to 0.524 squared. Okay, use your calculator. So AC should be 4.12. Unit jangan salah meter per second squared. And the direction. Okay, the direction is downward. So maksudnya bila rider tu tadi berada at highest point of the Ferris wheel, the direction of the centripetal acceleration should be downward. Okay? And C, the magnitude and direction of her centripetal acceleration at the lowest point. Sama juga sebenarnya nilai centripetal acceleration. Yang membezakan adalah direction sahaja. So at the lowest point, the direction of the centripetal acceleration is toward to the center. Ini center dia kan? So AC should be upward. But how about the centripetal acceleration? Tak perlu kira untuk jawab C ni. Okay, centripetal acceleration, the magnitude of AC still the same, 1.42 meter per second. But this time for C, the direction of centripetal acceleration should be upward. Okay, remember dia punya centripetal acceleration, sebab tu kita so remember that the direction, so remember that centripetal acceleration is equal to V squared over R. So dekat atas ataupun dekat bawah, the value of the centripetal acceleration is the same. Boleh? Okay, so question D, we want to calculate the reaction force. Reaction force of the chair on the woman means that the normal force. Okay, kalau reaction force on the chair on the woman, referring to the normal force. Kalau action force from the woman to the chair means that weight of the woman tadilah. So reaction force dekat sini kita nak kira the normal force at the top and at the bottom of the Ferris wheel if the mass of the woman is 53 kg. Okay, so kalau saya lukis dekat sini, awak tengok kita naik Ferris wheel, ni macam ni kan. So ini awak lah, ni pun awak kan. Okay, so at the top of the Ferris wheel, the normal force should be upward, but the weight of the woman should be downward. Okay, and at the bottom of the Ferris wheel, macam biasa, weight downward, normal upward. Okay, but look at the direction of the centripetal acceleration. Okay, at the top of the Ferris wheel, the direction of weight is same direction as the centripetal acceleration. Centripetal acceleration always toward to the center of the Ferris wheel. Sama jugalah masa dekat bawah. Okay, AC mesti towards to the center. But this time, the direction of normal force pula yang same direction dengan AC. Masa dekat atas tadi, W yang same direction dengan AC. Okay, masa dekat bawah, normal force yang sama. That's why, when we write the equation, kita buat dulu top total Fy ataupun FCy equal to MAC. Okay, look at here. At the top of the Ferris wheel, force apa yang sama dengan AC dia punya direction? W. So W should be positive plus negative N equal to MAC. So soalan tanya reaction force of the chair on the woman at the top. So we want to find N, right? Okay, so N is equal to W minus MAC. So N is equal to mg minus MAC. Ini kalau awak nak factorize pun tak ada masalah. Kalau tak nak pun boleh masukkan terus. Okay, so the mass is given 53 kg, 9.81 and AC is 4.12. Therefore, the normal force of the chair on the woman is equal to berapa tu? 301.57 Newton. Okay, the normal force at the top. Okay, when the okay, so second at the bottom of the Ferris wheel, what is the value of the normal force? Okay, kita sama juga, kita tulis total FC in Y component equal to MAC. So bila saya tulis total FCY means that centripetal force in Y component, in Y direction ataupun vertical plane. Okay, so look at the bottom here, the direction of normal force yang sama direction dengan AC. This time normal force yang positive. Okay, so N is equal to MAC plus mg. Therefore, N is equal to MAC plus g. So, let's substitute. M 53, AC is 4.12 plus 9.81. Alright? So, N you akan dapat 738.29 Newton. Okay? So, dah settle semua soalan bagi example number 9. So, let's proceed to example number 10, the last one. Okay? Okay, here we have a roller coaster. So, we have a 700 kg roller coaster car full of people goes around a vertical loop. Okay, that has a diameter of 50 meter. Ni semua perangkap awak lah ni, diameter. So given that the diameter is 50 meter, means that the radius of the circle is 25 meter. Okay, and this is the mass, 700 kg. So question, what minimum speed must the roller coaster car have at the top of the vertical loop to stay on the track? Okay, so look at here. Okay, draw the free body diagram. So now we have weight downward. Okay, so W, and then the normal force should be downward. So the force from the seat on the passengers is the normal force. Okay, reaction force there. Okay, downward. So when we write the equation, okay, so always remember, so when the roller coaster is moving with the minimum speed, okay, to maintain its circular path, the force of gravity, bila kita kata the force of gravity, means that referring to weight. Okay, the force of gravity alone is the centripetal force. Okay, maknanya kita nak kira what is the minimum speed. Okay, soalan ini so you need to consider n is equal to 0, means that no contact, we consider no contact between the track and the roller coaster. Okay, roller coaster car. Boleh maksudnya hanya ada force of gravity saja masa tu. Sebab tu dia tanya what is minimum speed must the roller coaster have at the top. Kalau terlalu perlahan tak boleh kan, bahaya kan. Dia kena bergerak laju juga untuk dia stay on the track. So in order to find the minimum speed, we need to consider n is equal to 0. Okay, so at the top, as we know that total FCY is equal to MAC, so we can write that n plus mg is equal to mv squared over r. Jadi untuk kira V minimum, berapa minimum speed yang sepatutnya ada pada roller coaster tersebut, we need to consider n is equal to 0. Keadaan bila n equal to 0 tu seolah-olah no contact between the track and the roller coaster car. Okay, so kita nak tengoklah. Kalau boleh, bila kita dah kira V ni nanti, V minimum, so kita tak nak roller coaster tu bergerak dengan kelajuan yang sangat rendah lah. Okay, sampaikan the normal force is equal to 0. So kita tak nak macam tu. Okay, so based on this equation, so you can cancel juga m. Okay, n equal to 0, mg equal to mv squared over r. Therefore, V minimum is equal to square root rg. Okay, so when we substitute the radius is 25 meter times 9.81, so you akan dapat V minimum, okay, is equal to berapa tu? Okay, 15.66. Awak cuba kira check balik. Okay, so the minimum speed is equal to 15.66 meter per second. So apa yang kita boleh cakap? The minimum speed the roller coaster car must have to go around a vertical loop, okay, of radius 25 meter tadi, okay, without falling off is 15.66 meter per second. Tulislah the minimum speed, okay, the roller coaster car must have, okay, paling minimum perlu ada adalah, okay, must have to go around a vertical loop of radius 25 meter without falling off. Apa dia? Is 15.66 meter per second. Kalau roller coaster ni bergerak lagi perlahan daripada 15.66 meter per second, tak boleh. Okay, tak boleh. Sebab nanti dia tak boleh stay on the circular track tadi. Okay, so the very minimum speed yang kita dah kira adalah 15.66 meter per second. Okay, so kita dah habis discuss semua soalan. Okay, 10 examples dalam chapter 6. So, see you in the next video. Thank you for your support and don't forget to share the videos with others. Okay, selamat berusaha. Jumpa lagi. Assalamualaikum. Bye-bye.